Hi, I'm Nitya, your tutor at Nityaz Academy. Let's learn applications of integration together, step by step. To find the area trapped between two curves, integrate the top curve minus the bottom curve across the region. The limits a and b are the x values where the curves cross. Subtracting bottom from top measures the vertical gap at each slice, and the integral adds all those gaps into one total area. Integration also recovers motion. Since velocity is the derivative of position, integrating velocity gives back the change in position, which is the distance traveled. Integrate the velocity function between two times, and you get exactly how far the object moved over that interval. Derivatives and integrals are two sides of the same coin. Find the area between y equals x plus 4 and y equals x squared from 0 to 2, where the line stays on top. Integrate top minus bottom, x plus 4 minus x squared. The antiderivative is x squared over 2 plus 4x minus x cubed over 3. Evaluate from 0 to 2. 2 plus 8 minus 8 thirds, which is 22 thirds square units. A particle has velocity 3t squared plus 2 meters per second. How far does it travel from time 0 to 2 seconds? Integrate the velocity. The antiderivative is t cubed plus 2t. At t equals 2, we get 8 plus 4, which is 12. At 0, we get 0. So the particle travels exactly 12 meters. Let's review. To get the area between curves, integrate top minus bottom between their intersection points. To get distance, integrate velocity over the time interval. The common thread is that a definite integral accumulates a quantity. Whenever you need a running total, area, or distance, integration is your tool. Great work! Keep practicing with Nitya at nityazacademy.com for free lessons, worked examples, and practice.